Hello everyone, myself Vinay Kumar. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. So in my previous video, I have started solving the questions which were there in exercise 7.2. So in my previous video, I have solved the 4 questions in this exercise 7.2. So starting from 5th question, I'll be solving in this particular video. So now we will look into the remaining questions which were there in exercise 7.2. So now coming into the 5th question in this particular exercise 7.2, here they have given one diagram. So let me draw that diagram. So you have two triangles like this. So let me draw the triangle. So you have one triangle like this, which is named as ABC, and there is one more triangle here, which is BDC. So here, this BDC triangle and ABC triangle are isosceles triangle. So that means AB is equal to AC and BD is equal to CD. Here, you have to prove that this total angle ABD and this total angle ACD are equal to each other. That is what they have asked in 5th question. So here the data which they have given is AB is equal to AC and BD is equal to DC. So now according to theorem 7.2, so if you don't know what is theorem 7.2, you can refer my previous videos where I have explained theorem 7.2 and theorem 7.3. So after understanding theorem 7.2 and 7.3, you can solve this particular question. So now according to theorem 7.2, if you have an isosceles triangle, then in that isosceles triangle, you will have two equal sides. Opposite angles of those two equal sides are also equal. So that means here the opposite angle of AB is this particular angle and opposite angle of AC is this particular angle, that is ABC and ACB. So this ABC and ACB will be equal to each other. According to theorem 7.2, angle ABC is equal to angle ACB and angle DBC is equal to angle DCB, because this down triangle is also an isosceles triangle because these two sides are equal to each other. So in this triangle, these two sides are equal to each other. So opposite angles of these equal sides will be equal to each other. So that is angle DBC is equal to angle DCB. So let me write this in a new slide. So ABC is equal to ACB. Let this be equation 1 and DBC is equal to DCB. Let's call this as equation 2. So now if you see this particular diagram, if you add angle ABC and if you add angle DBC, you will get the total angle ABD. So that means here the total angle ABD is equal to angle ABC plus here this is the angle ABC and this is the angle DBC. So plus angle DBC. Similarly, if you consider this particular total angle ACD, then that is the sum of ACB and DCB. So here the total angle ACD is equal to angle ACB plus DCB. So here in equation 1, so let me call this as equation 3 and let me call this as equation 4. So here you can see in equation 1 we have ABC is equal to ACB and in equation 2 we have DBC is equal to DCB. So now substitute, so now you can substitute equation 1 and equation 2 in equation 4, because in equation 4 you have ACB and DCB. So here ACB is equal to ABC, DCB is equal to DBC. So let me rewrite this equation 4. So ACD is equal to, in the place of ACB, I can write this particular ABC. So ABC plus in the place of DCB I can write DBC. So ABC plus DBC. So this you can call as equation 5. Now you can compare equation 3 and equation 5. So I'll write equation 3 and equation 5 once again. So ABD is equal to ABC plus DBC. This was equation 3. And equation 4 we have rewritten as equation 5, that is ACD is equal to ABC plus DBC. So this is equation 5. Here you can clearly see RHS are becoming equal to each other. So therefore LHS should be equal to each other. Therefore ABD is equal to ACD. So here also in the question they have asked, you have to prove ABD is equal to ACD, and we have proved that. Now we will look into the sixth question in this particular exercise. Here in sixth question also they have given one particular diagram. So let me draw that particular diagram. So you have a triangle like this, which is D. This point is named as D, C, B, and there is a point A here on BD. So you have to connect the C and A point. So that means AC is there inside this triangle DBC. So this particular side, this particular side, and this particular side are equal to each other. So here triangle ABC is an isosceles triangle. So that means this particular interior triangle which you can see here, this particular triangle ABC is an isosceles triangle with AB is equal to AC. So that means here one data we are getting, that is AB is equal to AC. And side BA is produced to D. So that means this ABC triangle, this BA is there, no, that is produced till D like this. So and this particular D is connected to C. So now AD is equal to AB. So this particular BA is produced up to D in such a way that AD becomes equal to AB. So one more data we have here, that is AB is equal to AD, which is also equal to AC. Because AB is equal to AC, so AB is equal to AD, so AB is equal to AD is equal to AC. So this is the data which they have given. Now you have to show that BCD is right angle triangle. So now according to theorem 7.2, so according to theorem 7.2, here since ABC is an isosceles triangle, this angle and this angle will be equal to each other, and this particular angle, even ADC is also isosceles triangle, so that's why this particular angle and this particular angle will also be equal to each other. So that is angle DCA and angle ADC are equal to each other. So according to theorem 7.2, angle ABC is equal to angle ACB and angle ACD is equal to angle ADC. So we'll just keep this aside. Now we'll consider triangle DBC. So consider triangle DBC, the total big triangle what we have here, we'll consider that. So here the angle BCD should be equal to 90 degree, then only this particular DBC will be a right angle triangle and this particular BCD angle will be 90 degree. So now we'll consider triangle DBC. In this we have to consider the angle BCD. So what is BCD? BCD is ACB plus ACD. So here you can see this particular angle is ACB and this particular angle is ACD. So if you add these two angles, you will get the total angle BCD. So now what is ACB? ACB is equal to ABC. Angle ABC is equal to angle ACB, and we have also written angle ACD is equal to angle ADC. So in the place of ABC, in the place of ACB you can write ABC, and in the place of ACD you can write ADC in this particular equation. So let's call this as equation 1. So now equation 1 will be equal to BCD is equal to, in the place of ACB I'll write this particular ABC because ABC is equal to ACB. So ABC plus, now in the place of ACD I can write ADC. So here ADC. So now we got the angle BCD, that is equal to ABC plus ADC. Now if you consider this particular triangle DBC, sum of interior angles of a triangle is always equal to 180 degree. This you have learnt in 8th standard mathematics. So you can refer my 8th standard videos also. I have taught all those things in 8th standard mathematics. So now the interior angles of triangle DBC will consider. So in triangle DBC, here interior angles are DBC, DCB and BDC. So here DBC plus BCD, BDC. So if you add all these things together, it will be equal to 180 degree. So here in the place of DBC, I can write this as ABC also, because instead of considering D point, I can consider A point also, because this angle I am taking. So either it will be DBC or ABC. Anything works. So in the place of DBC, I'll write ABC plus BCD plus, in the place of BDC, so we have BDC here. So instead of writing BDC, I can write this as ADC also, because I am considering this particular angle. So instead of taking BDC, I can take ADC only. So in the place of BDC, I can write this as ADC. So that is equal to 180 degree. So that means here we have ABC plus ADC plus BCD is equal to 180 degree. So here you can see in equation 1, we have written this as BCD is equal to ABC plus ADC. So here also we have ABC plus ADC. So in the place of ABC plus ADC, I can write BCD. So BCD plus BCD is equal to 180 degree. So BCD plus BCD will be 2BCD. So 2BCD is equal to 180 degree. So therefore BCD will be equal to 180 degree divided by 2, which is equal to 90 degree. So here they had asked to prove that BCD angle is equal to 90 degree, and we have proved that. So coming to the 7th question in this particular exercise, here you have to consider a particular right angle triangle like this. So here A is the right angle. The name of this triangle is ABC, where A is equal to 90 degree. And one more data they have given here, that is AB is equal to AC. So now you have to find out what is the value for B, what is the value for C. So now here the data which they have given is AB is equal to AC, and here angle A is equal to 90 degree. In isosceles triangle, so if two sides of a particular triangle are getting equal to each other, means that is an isosceles triangle. So since this particular AB is equal to AC, since AB is equal to AC, triangle, therefore triangle ABC is an isosceles triangle. So here triangle ABC is an isosceles triangle, and according to theorem 7.2, so according to theorem 7.2, opposite angles should also be equal, which is opposite to the equal side. So these are the equal sides. So the angles which are opposite to these equal sides, that is this particular B angle and this particular C angle. So C is opposite to this side and B is opposite to this particular side. So now these B and C will be equal to each other. B is equal to C. So now here we have is equal to 90 degree, and we don't know what is B and C, but we know that B is equal to C. So now A is equal to 90 degree, and sum of interior angles of a triangle is always equal to 180 degree. We know this. So now B is equal to C. So in the place of C, I'll write B only. So B plus B. That is angle B plus angle B, which is equal to 180 degree, because B is equal to C. So since B is equal to C, in the place of C, I am writing B. So angle A plus 2 times angle B, because B plus B is 2B, so which is equal to 180 degree. Now 2B is equal to 180 degree minus A. What is A? A is 90 degree, so 180 degree minus 90 degree will give you 90 degree. So that means 2B is equal to 90 degree. So B will be equal to 90 degree by 2, because 2B was there. When I bring that 2 to RHS, it will go to the denominator. So 90 degree by 2 will be equal to 45 degree. This is also equal to angle C, because B is equal to C. So therefore B is equal to 45 degree and angle C is also equal to 45 degree. So now we'll move to the 8th question in this particular exercise. Here, show that the angles of an equilateral triangle are 60 degree each. So what do you mean by equilateral triangle? You have a particular triangle like this. So let's say this is an equilateral triangle ABC. So in equilateral triangle, all 3 sides will be equal to each other and all 3 angles will be equal to each other. So you can write that in equilateral triangle. So in an equilateral triangle, all angles are equal to each other. All angles and all sides are equal to each other. So now sum of the interior angles of triangle is always equal to 180 degrees. So that is angle A plus angle B plus angle C. Before considering angle A, B and C, let's consider the triangle. So now consider equilateral triangle. Consider equilateral triangle ABC. And in a triangle, all the angles, if you add all the interior angles, if you add, that will be equal to 180 degree. And we know that angle A is equal to angle B is equal to angle C, since triangle ABC is an equilateral triangle. So since triangle ABC is an equilateral triangle, angle A is equal to angle B is equal to angle C. So therefore angle A plus angle A plus angle A will be equal to 180 degree, because in this equation I have taken A, B, C. So now A is equal to B is equal to C. So in the place of B I can write A, in the place of C also I can write A. So that's why I have written angle A plus angle A plus angle A is equal to 180 degree. So 3 times angle A is equal to 180 degree. This means angle A is equal to, if you bring 3 to RHS, it will go to the denominator. So 180 degree by 3, angle A is equal to 60 degree. Now angle A is also equal to angle B, which is also equal to angle C. And we know that angle A is 60 degree. So B will also be 60 degree and C will also be 60 degree. So that's why here in an equilateral triangle, all the interior angles will be equal to 60 degree. So that is what they have asked to prove in this particular question, and we have proved that. So this is all there in this particular video. This comes to the end of exercise 7.2. So there are few more concepts after exercise 7.2, and there is exercise 7.3 which is left in this particular chapter that I will be teaching in my next videos. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.